Morning. Welcome to what I'm going to call one of the two, I think, toughest lessons. It's really cool stuff, which is what I think of, pretty much everything, but this is definitely going to be a little bit of a challenge. So what I'm going to do is tomorrow I won't post anything new. I'll give you an extra day just to kind of get your cells wrapped around this concept, because then we're just doing the linear one today, you can see, and then the quadratic one. In order to understand that one, of course, you need a decent understanding of the linear one as well. So then for these next two lessons, I'll kind of have just a day in between where I won't post anything, and then we'll get back to our regular pattern. I also have tweaked the notes a little bit to help you, but my completed notes are very similar but not identical. So again, just to give you a heads up. So we're going to be graphing reciprocals of linear functions. And so, of course, we know with the reciprocal, the concept of that means we swap the numerator and the denominator. So I've given you the x values, and just to make it a little bit easier, because that's definitely not what I need. But this is the one where I'm going to go through the detail explaining it. So again, just to make it a little bit easier, I'm just going to put a y here. And I'm going to put a y here. So basically, we're going to graph y equals x, which I know you did in grade 9, right? So each x value will be the same as the y value. So of course, this is just a carbon copy. And there's reasons why I chose these values, of course, right? So the good news, oh, I forgot to take out my ruler, is that this one will be fairly simple to graph. And of course, this is the basic one, right? Okay, so we have that one there. All right, and so now when we graph the reciprocal, what we're going to do is we're going to take each value that we have and, of course, swap the numerator for the denominator. So when we look at this, I'm just trying to think of which one's going to stand out here, right? So for this one, it's really negative 4 over 1, so we're going to write it as negative 1 over 4, okay? Negative 1, what's the reciprocal of negative 1? Well, it's just negative 1, right? The reciprocal of negative a half will be negative 2. Now, when we think of 0, right, 0 over anything, so 0 over, except 0, of course, 0 over 2, let's say. Well, when we flip it, we have 2 over 0. We know, and if we forgot, we can type it into our calculator, that dividing by 0 is undefined, right? Undefined. So that's just not an option, and of course that's definitely going to affect our graph, right? And then flip, flip, and flip. Okay, so and this is where it gets really, really interesting, right? So what we're going to do now is we're going to try to graph this with this, and this, etc., etc., and then we'll see what that looks like, right? So this is going to be tricky, but at least you can see it. So negative 1, 2, 3, 4. These are a little tricky on the graphs. Negative 1, yep. Okay, negative 1 half, and negative 2. Oh, that's looking familiar. 1 half, 2. I skipped this one, by the way. We'll come back to it. And, oh, shoot, that should be 1/4. I forgot to flip that. 1, 2, 3, 4. There we go. So I'm going to leave it for now. Okay, and then I'll come back to it and I'll draw it for you just to see what it looks like. So I'm going to write in pencil because I think it's easier to see than the blue. Plus it's harder to write with the blue. So let's look, excuse me, at the non-permissible value, right? We know that x can't be 0, right? So if x can't be 0, what that means is that these graphs will never, ever touch the x-axis. So that means there'll never be any x-intercepts, right? So no matter how large of a number we pick for this one, right? No matter how large of a number, it'll be 1 divided by it will be incredibly tiny, but because it can never be 0, right? It'll never ever be 0, so we have no x-intercepts. So what happens then is we have these vertical asymptotes then, which are imaginary lines the graph will get extremely close to, but will never touch. And these will occur at the non-permissible values. And we already know that vertical asymptotes, vertical lines, right? So it will always be x equals whatever your non-permissible value or values are. And in this case, x equals 0. So now what I'm going to do is I'm just going to go back. Right? Here's where x equals 0, undefined. And so what we have to do is we have to draw a dotted line. I'm trying to draw it just off so that you can see it. I don't know if that worked very well, but anyway, okay. And then there's also what's called a horizontal asymptote. Now for us, it's always going to be the same, so that's really nice. So it describes what happens when the absolute value of x is very large. So as x approaches infinity, y equals 1 divided by a really, really large number. So y is going to approach 0. And so then we draw another one here. Now, the vertical asymptotes are going to change for us, but the horizontal ones will not. One will not. Not for us, anyway. Pre-calc 30, I make no promises. So, what that means now, because we know it can't cross this and it can't cross this, because we have our 3 points, when we draw them, we get these really unique curve-looking things. So what I've drawn in blue in the first quadrant and the third quadrant, that's the graph of y equals 1 over x. That's what it is. And then we still have our invariant points, which are the same or same concept as what we did with the absolute value, but they will occur at the points where the reciprocal has the same value. So only where y is 1 and -1. And we found that out here, right? Because when we took the reciprocals, we got the same thing, and those are the only points. So it requires a little bit more work when you're calculating it, just because they're reciprocals. That's just what I explained, okay? So hopefully that went over fairly well. So complete the table and graph the linear function as well as the reciprocal function. And so this is where you'll see that my notes are a little bit different. I was trying to match it up a little bit more to the assignment. So you can see I don't actually have a table of values anywhere, right? Because that's definitely not necessary. So what we want to do first is we want to graph 2x minus 4. And so that's where we'll most likely use the slope and the y-intercept method. Okay, so y-intercept of -4, 1, 2, 3, 4, positive slope of 2 over 1. And I always recommend drawing a few of those points. See if I can... I find these pencil crayons don't sharpen as well. There we go. It's not my best one, but hopefully it'll work. It's pretty thick though, okay? Hopefully that'll be easy to see. Alright, so I'm going to move over here now, and I might have to zoom out a little bit. We'll see how that goes. So the coordinates of the y-intercept, and bear with me here while I kind of talk you through this one. We still do the same thing that we always have done. We put a 0 in place of the x, right? So y equals 1 over 2, and this gives us a point, which we need. So we get 1 over -4, which is that. There we go. So the equation of the vertical asymptote. Now, I don't need you to tell me that the denominator can't be 0 like we did way, way, way back when. Okay, but that's what it is. So this can't be 0. And so what happens when we solve for that, we end up with, right, what value can we put in for x where that would work the denominator out to be 0? Well, that would be 2. So the equation of the vertical asymptote is x equals 2. And we can see that already because where does that orange line cross the x-axis? At 2. That's where we're going to draw our vertical asymptote. This always stays the same. Okay? And this is where it gets a little bit interesting. right? And this is tricky, and I have to admit, when I first started this, I kept catching myself because I'm used to not putting in numbers for y. I'm used to putting them in for x. So this kind of tripped me up a little bit, right? So we know that the invariant points are going to occur when y is 1 and negative 1. So this is where we put, doesn't matter which one you put first. Okay, so there's that one. And moving over a little bit here, and this one. So we have to solve both of those to get our x values. And I think the easiest way to do that is just cross multiplication. So 2x minus 4 equals 1, 2x equals 5, x equals 2.5, right? What do we got here? Negative 2x plus 4 equals 1. So negative 2x equals negative 3, and x equals 3 over 2. Kind of running out of room here. So let's see. Yeah, I'm going to just tuck them right here. So 5 over 2, that's what I used to do. I think I used to calculate it correctly, but then I would flip these two. But the nice thing about that is I would go to put them on the graph and realize that they didn't work, so then I would fix it. So just be careful with that. It's a little bit tricky. So now before we get to this one here, we're just going to put all the information that we have on there. Okay, so I'm going to start with my asymptotes. So I'm going to put x equals 2 in here. You just can't really see me drawing that, not that you need to, but anyway. Has to be a dotted line. Okay. And you'll start to see these patterns when you graph them, right? Because you can't just have any kind of graph for these. And so that's what I think is pretty neat about it. One of the things, anyway. All right. So those are my asymptotes, okay? So what we want is we want to have at least 2 points per section. We're going to know what happens with these asymptotes, right? Because we know they can't cross them, or they can't even get to them, right? So we're going to plot our y-intercept, 0 and negative 1/4. I put those in already. We're going to plot our invariant points. And the nice thing about these two is that when I put these on there, they should end up on the what? On the orange line, because they're invariant, meaning that they're the same. And if not, it just means I made a mistake. So let's go 2.5, 1, 2.5, 1. Yep, there it is. And 1.5, negative 1, 1.5, negative 1, and there that one is. So you can see we have, oh good grief, gonna move this over. You can see we have these two for this section, okay? And even though we already know what's gonna happen, we only have one up here. So we need a second one. We need one for each section of it. So we need to pick something over here and do a little bit of a calculation. So, and it doesn't matter as long as it goes beyond, what do we have here, 3. Right, the further you go, what's going to happen, right, is you're going to get a smaller and smaller fraction, which are obviously hard to graph. But I made sure on your assignment you have some pretty large graphs to do that. So I am going to choose, I'll go with 5. So that's the value I'm going to use. So 1 over, I only need 1 this time, right? So 5 and 1/6. So you could have used, right, 4, 6, anything like that, and obviously you'd get a slightly different fraction. So 1, 2, 3, 4, 5. 2, 3, 4, 5. There we go. And then, of course, now we can draw it. And you want to try and draw it as accurate as possible, but it is a little tricky sometimes. That one got a little bit warped. And there we go. Now, one more. So, and not one more example, because it also says that if I give you a line, that you can draw the reciprocal of that function, and both ways, right? So I'm not going to make this super complicated. The first thing we need to do, though, is we want to write the equation of the original function. So in order to write the equation of a line, going back to foundations in pre-calculus 10, we need the slope and the y-intercept, right? So this crosses the y-axis at 3, and because it's a decreasing line, it has a negative slope, right, and I can see my rise over run is 1 over 1. So first thing we're going to do is negative x, right, plus 3. So write the equation of the original function, write the equation of the reciprocal function. So we're going to go 1 over. Now, we know from the very, very first unit that we don't like to leave a negative at the beginning. That's why I reversed it. Don't stress yourselves about that, okay? So what do we know about the vertical and the horizontal asymptotes? Well, we know that our horizontal asymptote is going to be y equals 0. So I'm going to draw that in right away. That one did not go well. I better use a different color here. And so what I want you to do is look at where is the vertical asymptote going to be. Drawing the horizontal. Oh, darn. There we go. Okay. Well, we know it's going to be at our x-intercept, and we can see where it crosses, right? That's nice when it's already drawn for us. We don't even have to do that. So we'll put that in right away. Okay, so now we have that. So it says write and draw the equation of the vertical and horizontal asymptotes. So we put in x equals 3 and y equals 2. So we will, y equals 0, sorry. I heard what I said at least. Calculate the y-intercept. So y equals 1 over 3 minus 0. Okay, so we have that now. And now we'll calculate the invariant points. So that's the 1 equals 1 over 3 minus x. And so I'm just going to go a little bit faster here. X equals 2. And then negative 1 equals 1 over 3 minus x. X equals 4. So always important to write those out. Okay, and then this is where I would normally, I plot them and then I figure out what else I need. So 0, 1/3, 2 and 1, 2 and 1, yep, there it is on that one. And then 4 and negative 1, and it's on that one as well. So I can see I have my 2 points in this section, but I need another point over here. So I'm going to go back and calculate it. I'm going to use 6. And then, so 6, 1, 2, 3, 4, 5, 6. And you can see now, and I won't exactly use quadrants, but you can see what happens as the vertical asymptote moves, right? That's not my best graph, but anyway. So you can see now that when we did the first one, we were in this quadrant and this quadrant. And why do you think we're in, I'm going to say the upper left and the bottom right? Well, it has to do with the fact that we have started out with a decreasing line, right? So what I've done is I've attached, well, I think I added the answers to the assignment. I used to just post it up on the smartboard, but I added the answers, but I am going to attach the graphs for you so that you can check with yours. So make sure you do this one, because if not, we also have to do the reciprocals of parabolas, if you can imagine. And so those are a little bit different, obviously. So make sure you do that. So I'm going to skip a day, and then I'll give you the quadratic one, and then I'll skip, and then we'll wrap up this unit. So talk to you soon.